Hello my dear viewers, have a great day. I am Mrs. Deepa Priya, working as Assistant Professor in Department of Information Technology, Kamraj College of Engineering and Technology, Virudhunagar. Today we are going to see about searching techniques in data structure. There are two searching algorithms are available in data structure, linear search and binary search. Now let's see about linear search. Linear search is the simplest searching algorithm. It checks each element from the array and compare it with the searching element. If the searching element is found in the array list, it will display the element found message, or otherwise element not found message will be displayed. So this is a linear search algorithm procedure. In this procedure, we are going to start from the first element of the array. We have to start it from the starting element of an array, compare each element with the target value. Our target value is the searching element. So we have to compare each and every array element into a searching element. So we have to compare the searching element and the array element. If the element matches, it returns its index. So if the element matches means if the element is found, then we can return the index. If not, we have to continue to the next element. If the element is not found, so we have to repeat all the elements again and again, but we are not getting the result, then element is not found in that particular list. Then we can return a -1 here. So next we are going to see about the pseudocode for the linear search for I from. So your I value ranges from 0 to n-1, and we can take the element if array of I. If array of I means your index is 0, right? So ARR of 0 which is equal to key means key is a searching element. If both are equal, then we can return the 0, or we have to repeat the loop. So next element is 1. ARR of 1 is equal to key. If it is not matches, ARR of 2 is compared with the key. If it is not matches, ARR of 3 is compared with the key. So until the match found. If all the elements gets over in the list, then automatically the element not found message, we have to display the element not found message. So we have to return a -1 here. This is a example problem statement. The given array contains 5 elements, 5, 12, 7, 20 and 25. I am going to search element 20 here. What we are going to do? So this 20 is compared with the 5. If 5 and 20 are equal, no. So automatically the index moves to the next place 12, and then we can compare 12 and 20. 12 and 20 are equal, no, and we can move the position to the second position 7. So 7 and 20 are equal, no. Next position, we are moving to the next position. So 20 and 20 are equal, yes, both the values are equal. Then we can return the position as, what is the position we are going to return? 0, 1, 2, 3. Third position will be returned to the user. So this is the demonstration of the algorithm. So initial index is 0, 0th position index value is 5, 5 and 20 are compared with each other. So 5 is not equal to 20, so the result is no, and the first position element is compared with the 20, 12 is compared with the 20, the result is no. 7 is compared with the 20, the result is no, and 20 is compared with the 20, both are equal. So the element found message will be displayed to the user. Next we are going to give the another element. For example, the key element to be searched is 100. So we have to begin the search by using 5. So 5 and 100 are compared together, the result will be no, because 5 is not equal to 100, and 12 and 100 are, we are going to check 12 equal to 100 means we are going to compare 12 and 100, both are equal, no. 7 and 100 are not equal, 20 and 100 are not equal, 25 and 100 are not equal. So your array list is over. Once the array list is over, what happens is that the element is not found. So the element is not found message is displayed to the user. This is the C code for the linear search. In the linear search for loop, your initial value is 0, and we can proceed with I less than n-1 I plus plus. If ARR of I, that is the index position element, ARR of 0, that is first position, that is 0th position, which is equal to key means we have to return the index, or otherwise we can return a -1 here. So in the main we have to set up the array and we can set up the key value, and we can find the n by using size of array. Array element is 5 elements and we can divide it by array of 0 means automatically we will get 5 elements here, and we can call this linear search algorithm. So this linear search will call this function. So automatically what happens is that this 20 is present in the list, right? So 5, 12, 7, 20 is available. Our key search element also a 20. So this element is found. So the result contains the key position. The key position is 0, 1, 2, 3. 3 is written to this result. So after that we will compare if result not equal to -1. Not equal to -1 means element is found. For example, if you are going to return any index means it must be starting from 0 to any value. If the element is not found, we can send -1 here. So if result not equal to -1, print element at a index, we can display that index, or otherwise element not found message will be displayed. This is about the linear search algorithm. Next we are going to see about the binary search algorithm. There are lot of difference in the linear search and the binary search. In the linear search we do not want any shorted array list. But in the binary search, once we are going to search the element, first we need to give the input in the sorted order. And next we have to divide the element into two halves by means of divide and conquer strategy. What is called a divide and conquer strategy? First we have to divide the problems into subproblems. After that we have to combine the solutions of the subproblems to find the solution for the whole problem. Okay, that is called the divide and conquer strategy. Here in the binary search we are using the divide and conquer strategy. So binary search is an efficient algorithm for finding an element in a sorted array. So we are going to give the input as a sorted array. It repeatedly divides the search interval in half. So we have to search interval, that is we have to divide the elements into two halves with the help of mid value. We will discuss it later. Much faster than the linear search for large data. It is very faster because if the element is found in one half, then we are not going to search for another half. That is the very interesting one. The array must be sorted. So array must be a sorted one. Works only on random access data structure. It works only for a random access data structure. So this is a binary search algorithm. In the binary search algorithm, what we are going to do is, first we have to set up low equal to 0. So we are starting from 0th element, right? So low equal to 0. And next high equal to n minus 1. What happens is that we have to set up the high element to be a n minus 1 means last element. And we can check the loop while low less than or equal to high. So your low less than or equal to high means you have to proceed with this loop. And we can check ARR of mid. What is called mid? What is called mid? So we have to find the mid value by using low plus high by 2. Low plus high by 2 means, for example, 5 elements in the list means 0 plus 5 divided by 2 means the answer is 2. So your mid position is 2. And we can compare the mid position 2, that is array of 2 is compared with the key element. So in the mid position element is compared with the key element. If it is found, that is your mid position element is the key element, then we can return mid. Or otherwise we have to check if your key, for example, I am going to search 20, my mid element is 15. So it is not found, right? Key element is less than the array of mid element, then we can move the high pointer to the mid minus 1 position. So your searching element is less than the mid element means you can set up the high pointer to mid minus 1. Or if your element is greater than the mid element means you can transfer the low position to the mid plus 1 position. That is given in this procedure. So this is a pseudocode for this binary search. So first we can set up the low equal to 0, high equal to n minus 1, while low less than or equal to high, and we can calculate the low mid here. Mid equal to low plus high by 2. After that we have to check the mid element with the key. If it is found, then we can return the mid element, or otherwise we have to check whether my key is less than the mid element. Then we can move the high pointer to the mid minus 1, or otherwise we can move the low pointer to the mid plus 1. If the element is not found, it will return a minus 1. So this is an example of how the binary search is working here. So the element is given. So see here, this is a shorted array 10, 20, 30, 40, 50, 60, 70. I am going to search for 60. Okay, what about your low value? Low value is 0. What about your high value? High value is 6. What about your mid value? 0 plus 6 by 2, 3. And third position element is, what is third position element? 0, 1, 2, 3, 40 is the third position element. This third position element is compare with the 60. 60 is greater than 40, right? So search right low equal to 4. Now we have to set up low equal to mid plus 1. Okay. So if your searching element is less than the array index, means we have to set up what we are going to do. Your searching element is 60 and your array position element is 40. Your searching element is greater than the array position element, means we have to set the low value to mid plus 1. Okay. So now low value will be 4. What is, where is 4? 0, 1, 2, 3, 4. So now my low value is 4. 4 to 6 we are going to search. 4 now low equal to 4 and high equal to 6. What is the mid value? 4 plus 6 by 2 means the mid value is 5, and fifth position element is 60 and my key element is also 60. So both are equal, then found at index 5 will be written. So this is about a binary search, and the key value is found in that list. Next we are going to search the 100. We are going to find 100 here. So here what happens is that the same example, we are going to take the same values. So here low value is 0, high value is 6, mid value is 3, array of mid contains 40, my comparison value is 100, and my array value is 40. Your key value is greater than 40. What happens is that you have to set up low equal to 4. Now in the next step, low equal to 4, high equal to 6, mid equal to 4 plus 6 by 2 means 5, and your array of mid value is 60, and we can compare 100 is greater than 60. So again we have to set up low equal to mid plus 1. Mid plus 1 means what is the value of the mid? 5. So your low value is 6, and we can compare 6. Low is 6, high is 6, and your mid is 6, and our array of mid is 70, and we can compare 100 greater than 70. Yes, 100 is greater than 70. Now your low value will be mid plus 1. What happens is that the total element present here is 0 to 6, but your low position value is 7. So automatically the loop will be exit, and it will display element not found. So this is a binary search program in C. The same whatever we discussed in the pseudocode, it is same as here. And this is a comparison about linear search and the binary search. Array requirement can work on unshorted or shorted array. Linear search is very simple. It can be work for shorted or unshorted array. For the binary search, it works only on a shorted array. And approaches sequential checks from start to end. We have to check the elements from start to end. We have to check all the elements. But here binary search, divide and conquer strategy is used to find the middle element, and we have to swap the low pointer or high pointer to mid plus 1 or mid minus 1. Thank you.